start the slideshow. That works from the beginning. Oh, well, I guess. Windows, what are you going to do? Um, okay, so I'm here today to talk to you about peering economics. Um, the topics I'm going to cover today about peering economics are why peering is never free, when peering is worth the investment, how to develop a peering strategy, and how to be a good neighbor. So the reason why peering is never free is because it actually costs money. We just don't think about how much. Peering is a connection between two network devices, and of course, network devices require money. People are needed to configure and maintain network devices. People are not free. As a matter of fact, people are probably the most important cost in any of your networks. Something wrong? Um, sorry. Um, I, I, I don't really. What should I do? I'm sorry, I'm being told I have feedback and I'm not really sure how to accommodate that. Right.
I think you sound fine, Susan. I'd carry on. Feel free to pop your camera on as well if you'd like people to see you as well. It's up to you.
Oh, yeah, I did have that on, so I must have accidentally turned it off. There we go. All right, sorry. All right, back to our story. Um, okay, so, and then network devices, of course, need electrical power and a space to occupy. Yeah, you need a place to rack them. So power and space are not free. They charge money for those. So these are all things to consider when you're thinking about joining an internet exchange. So while peering has a cost, for any business uh, case, you're going to have to know what the value is for that and to get that return on investment. And to determine the value, you're first, of course, going to need to know how much your port costs. Besides the cost of the actual port on your equipment, don't forget the optics, the power, the support costs for having something in a facility. How much a cross connect costs in the facility at the data center that hosts the exchange, and don't forget the setup fees. And while it's true that you would have to have most of these things if you were going to connect to an ISP in a data center, this is a good exercise. If for no other reason, it'll help you when that accounting guy comes along and asks you for your budget for next year. So to make this a little bit easier to understand, I've come up with this handy chart showing the difference in cost between an internet service provider and an internet exchange. And I've used kind of broad numbers to make the math easy. Your mileage may vary, but this is just for purposes of illustration. So for an ISP, the one-time costs for a device port are the $200 for the port. That's what I figured it costs on a piece of equipment if you're consuming a port. The setup fee for the cross connect, $500 in both places. That's the same. Setup fee for the service. I've noticed that the ISPs tend to be a little bit less than the IXs for the service. I put $250 for the setup fee for the ISP and $500 for the internet exchange. And then after, so once you get those sunk costs out of the way, you have to think about the recurring costs you're going to pay every month. So I'm assuming a 10 gigabit port and a 2 gigabit commit, which is relatively standard. And I'm going to say that commit price per month is $2,000. And then if you exceed above that megabits, or exceed above that 2 gigs, I'm going to say it's $1 megabit for easy math. Of course, we don't have a price per port here. And then we have price for the cross connect. And then over on the side for the IX, we have we don't have a commit level and a commit price and price per megabit because you're free for those nasty 95th percentile billing when you're on an internet exchange. So then we just have the price per port and the cross connect, So that's our monthly recurring costs. So then if we take all of those numbers, then we have the information that on what it's costing us. Then we need to see if it makes good business sense based on cost. And if we take a look at that, I have this little graph that shows you, okay, This is graphed from 500 megabits to 8 gigs. It was just easier that way. I tried going to 10, but just made the slide long and kind of an eye chart, and it's bad enough as it is right now. So if we look at that, the ISP obviously is a lot more expensive. You know, it starts out, relatively high comparatively to the internet exchange. And then as they both converge a little bit, the internet exchange still stays very competitive, ends up around 20 cents a megabit at 8 gigs, while, we're, attenuating toward $1 per megabit on the internet exchange or on the ISP. So we are, clearly saving money on the internet exchange if we're just looking at it on the flat rate. But it doesn't really work that way, because you have to have some transit. Not even Hurricane Electric can get all of its internet connectivity from peers. So we have to have some traffic going to an ISP and some traffic going to the exchange. And for the sake of easy math, what I have done on this chart is put 50% of the traffic on the internet exchange and 50% of the traffic on the IX. So we have our original chart lines from the last chart for the ISP and for the exchange. And then that center line is the actual cost per megabit if 50% of the traffic were on both exchanges. And so it still looks pretty good. But there is one more thing you need to take into consideration when you are configuring these costs, and that is that pesky commit price. So actually, if you've got 50% of your traffic on the internet exchange and 50% on an IX, you're going to have 4 gigs of traffic before you meet that commit on your ISP. And that, commit is just money falling on the floor if you don't use it. So it's really important to keep these things in mind when you're trying to figure out whether or not joining internet exchange is a good idea. So then, in addition to our monthly recurring costs and our sunk costs, don't forget to factor in your operational support costs and save by streamlining and automating them. Because remember, I did say that people were going to be your most expensive investment in this. So create peer groups for your neighbors, so it takes people less time to configure them. You may want to automate that. Consider the support priority. You may not want to wake up your expensive engineers to reconnect a peer on an exchange if it's not very important. So you might want to do that. And then monitor your port capacity on the internet connections and increase it before you get into trouble. This is important because that port fills up faster than you know it. And so you really should be keeping an eye on it to make sure that you don't drop packets on the floor. Now, in an investment for your network, sometimes performance is just as important as money. So peering can provide tangible benefits in terms of reduced latency and improved throughput. You're going to gain more diversity at your edge, which will help you, and this will improve traffic. It will improve your traffic management and can help your routers rebuild their tables faster, more quickly when a link goes down, if not all of your traffic is in one basket. And it improves the scale of your network and prepares you for future growth. And this will result in internal and external customers being happier. So that is worth something. Now that we've talked about how much it's going to cost you and your business case, let's look at developing a peering strategy so you can get a better value out of your investment. The next thing to do is to target the exchanges that are going to have the most to offer and figure out who you would really like to peer with when you get to an exchange. So to determine if that port's a good investment, you should consider who your potential peering partners are on the exchange. Exchanges where you can reach content networks or cloud providers can be very advantageous. For example, if you are a Amazon, Microsoft, or Google customer on their clouds, and you can peer with them on an exchange, this certainly is going to make a big dent in your transit bill. Also, don't forget to peer with caching networks like Akamai, Fastly, and Limelight, because that's where a lot of your packets go first, and you can save a lot of money by peering with them. NetFlow and SFlow can give you a lot, SFlow can give you a lot of information about your traffic sources and destinations. And what I like to point out here is that it might not be what you expect. At one point, I was helping a university when I was working on the Boston Internet Exchange, try to figure out who to peer with. And they set up SFlow so that they could figure out which They were thinking which research organizations might be the most advantageous. And, they were thinking about, places like Microsoft and Google would be great. If you're thinking about this free flow of information on a college campus. But what they discovered was 75% of their traffic was going to streaming services like Netflix and Hulu. Because what they failed to factor in was that they were providing the internet service for the college dormitories. And that was where the bulk of the traffic was going, and the bulk of their transit costs were. So of course, the first persons we hooked them up with were Netflix. So that saved them a lot of money. But that's just an example of how you might want to take a look where your traffic is going, even if you think you know where it's going. So armed with all this information, you should start investigating some exchanges. Now, on bgp.ag.net, we have a list of all of the peering exchanges. And so you can browse through them and see which ones are close to where you are, or it might be advantageous to join and get, at relatively close proximity, or in cases of, some cases in cases of countries or geography might be better for you. So you can take a look at them. Now, since we're doing AppPIF, I'm going to take a look at NAP Africa. And if you click on the exchange, a little page pops up and gives you information about that exchange. And it shows you all of the people that are on the exchange, as well as links to handy things that the exchange has to offer. Like, for example, NAP Africa has a link to their peering traffic. So you can get an idea of the kind of traffic that's going across there. And if it looks like, that would be good for you. So a quick solution at most public peering exchanges, if you just want to get your feet wet, is to peer with the Internet Exchange's route server. And this will have some advantages for you. You'll only have a couple of peering exchanges with the route server, so that cuts down on the amount of work you have to do. And it's a quicker way to access many networks on the exchange. And even if you decide you want to peer individually with people on the exchange, you can still peer with the route server, but you may want to prefer any directly connected peers over the route server routes. The disadvantage of using a route server is you do have less control, and you may not get all of the available routes, because not all networks advertise all of their routes to the route server. Some advertise only a subset, so it might be advantageous to peer directly with them instead. And some networks choose not to peer with the route server at all. And then lastly, not all exchanges have route servers, although nowadays it is pretty common. So a peering strategy will help you get the most value from your exchange port, and you can evaluate these attributes first. As we mentioned before, are you reducing transit costs on that port? Can you send traffic to this peer that you otherwise would have to send on your transit connection? And are you going to get a lower latency? Again, for the example of cloud providers, in addition to saving money on your internet connection, it probably is going to improve your performance. And do you have excess bandwidth on your IX interface and on the ingress egress interfaces on your router? And this is an important question, because it can get very exciting to start turning up a bunch of peers, and then you turn up a big one and discover that, oh, you're out of room, and that was maybe not such a good move. So always good idea to do these things in a maintenance window and make sure that you have enough capacity. So a peering strategy helps you look at the big picture as well as the small one. And I'm going to give you an example as to why you need to think carefully about your network architecture and traffic patterns. So in this diagram, I have a green network, and the green network has a satellite office, which is a little building icon in another country. And it's got a backhaul connection to that satellite office, and both the satellite office and the green company have a connection to the internet. And they like to do a lot of communication with a partner, which is the blue network. So everything's working really well. The green network has good connectivity. The satellite office has good latency. And then the green network discovers that there's an internet exchange that would allow it to peer directly with the blue network and save a lot of money on transit costs. But what it fails to take into account is that once it prioritizes that route for everything on its network, now the satellite office in another country, instead of going through the lower latency route through the internet to the blue network, is now going all the way back to the country for the mothership, across the internet exchange, back to the blue network, and then back the long way. So that's causing a performance problem. That's the kind of thing you need to keep in mind when you do these internet exchange, when you connect with a peer on an internet exchange, you need to think about how it's going to affect your traffic pattern internally and do the thing that is best for your network. You might need to lower priority on some routes or do geographic communities to help yourself out. A lot of peers will advertise those to you to make it a little bit easier, especially ones that are located in many places. So those are all things to keep in mind. Now we're going to talk about our last topic, which is why you should be a good neighbor. And peering works when it is a good experience for both parties because it's voluntary. So first, clean up your advertisements. You should not be leaking your private IP space or routes that don't originate from a public AS across to your peers. Be easy to keep in contact with by updating your routing and contact information in PeeringDB or on your local RIR database. Keep your IRR records up to date and create RPKI ROAs for all of your prefixes. And then while the other network you are peering with is probably a fine organization, trust no one. Set maximum prefix limits for your peers. And the reason why I tell you this is a story that I have from back when I was working at Microsoft, and I had a colleague that worked at another company, and I came into the Internet Exchange hub for the city of Seattle, which is the Westin building, one morning, and he was crawling out of the elevator half dead. And I asked him what had happened. He said, "Oh, one of my peers advertised the internet to me last night." And I looked at him and said, "You have maximum prefix limits set on your peers?" He said, "I do now. So don't let that happen to you. Set maximum prefix limits. Accidents happen all the time, and people do things they don't intend to. So don't be affected by it." And then while we're on that topic of not being affected, filter your routes to accept only the valid routes from your peers, again, so you don't accept things that you wish you hadn't. It's easier to create a filter for your peers than you might think. You can use a tool like BGP-Q3 to generate a prefix list. I've got an example here where I've done it for a Juniper router. I've just typed in BGP-Q3 -J for Juniper, -6 for the IPv6 list I'm creating, an L so I can give it a name. And then BGP-Q3 pops my configuration out right there with all of the prefixes that are allowed for that AS. Simple. You can even automate it. So also be responsive when you're notified of an issue. Nobody likes a network that ignores them, especially if they're experiencing a DDoS attack or one of your customers is doing something naughty that they want you to stop. No one can take advantage of you without your permission. You're the one that controls your advertisements. So, control your advertisements and make sure that your traffic is going where you want it to. And at the end of the day, not all networks are going to want to peer with you. And this is usually more of a problem with their peering policy. It's a case of it's not you, it's them and their strategies. But even if they decide not to peer with you, it's always a good idea to check back later, because sometimes people aren't peering for capacity reasons, or maybe they're moving to a different location. And if you keep contacting them, sooner or later, you might be successful. So be persistent. So the internet turned 50 on October 29th, which means it's almost 51 years old, and peering exchanges began to be formed in 1993. They haven't gone out of style. During the pandemic, 7 of them have formed this year. And the reason for that is because exchanges are the backbone of the internet, and they have been able to improve our networking in ways that transit providers just can't. Communities form around exchanges that are invaluable for you getting connections and involvement that you would not ordinarily be able to have if you didn't belong to an exchange, and get benefits that aren't available from other sources. So joining an air exchange, has will do a lot for you besides just decreasing your transit costs. So that's all I had today about how to do peering economics, and I am ready for questions.